Good morning. Today, number 7. We are celebrating 133rd birth anniversary of great scientist C.V. Raman. He was the first Asian to win the Nobel Prize in 1930. By celebrating this day, we are expressing our dignity and respect to the great scientists for the contribution of science and technology. In spite of being a Nobel Prize winner, he was a true Indian because once Cambridge University offered a professor job and he declined it and saying he was an Indian, he wanted to serve his nation. Now, I would like to call up students to throw some lights on the life of Sir C.V. Raman and his discovery of Raman effect.
Good morning everyone. Sir Chandrasekhar Venkat Raman, C.V. Raman, a well-known Indian scientist. He was born on 7th November 1888 in Tamil Nadu. He was the second of 8 siblings. At the time of his birth, his father, Chandrasekhar Ramanand Iyer, earned a salary of 10 rupees per month. His life started from there to become the first Asian to receive a Nobel Prize in Physics. That story is an inspirational one. He earned BA and MA degree from the University of Madras, where he stood first and won gold medals in physics and English. Along with his studies, he continued his experiments too. He quit his job in government service for his inventions. He gave major contributions in the field of optics and acoustics. Finally, overcoming all the obstacles, he won the Nobel Prize in 1930 for the discovery of Raman effect. India honored him by giving Bharat Ratna in 1954. The Raman effect was about scattering of light on obstacle material with the formation of spectral lines. He won the prize at a time where there were no sophisticated equipment for research. He worked on musical notes and the colors of sky and sea. As quoted by him, the essence of science depends on thinking and hard work. This is portrayed in his life too. His life comes to an end on 21 November 1970. He is truly an inspiration for the younger generations. Proud to be an Indian. Thank you.
Good morning one and all. I am Nismavi, you studying in Concord English Higher Secondary School in 10th standard. White light is a composite light. Any light that is composed of more than one color is called composite light. White light has 7 colors. We can see the 7 colors of white light by using a prism. The 7 colors has different wavelength. As the wavelength increases, the frequency decreases, energy decreases. Red has the longest wavelength, its frequency decreases and energy decreases, so red is seen dim. Violet has the shortest wavelength, its frequency increases and energy increases, so violet is seen brighter. The reason for splitting of 7 color is due to dispersion. Dispersion is the phenomena of splitting up of a composite light into its constituent colors. The regular array of colors is formed by dispersion is the visible spectrum. Rainbow is also caused by dispersion. You have seen the 7 colors of white light using prism. Thank you.
We will discuss the principle of Raman effect and understand how it can be used in Raman spectroscopy to perform analysis on a given sample. Let us first understand the Raman effect. When a sample is exposed to monochromatic light in visible region, the sample absorbs light and major portion of the light gets transmitted through the sample. However, a minute part of the light is scattered by the sample in all the directions. One can observe the scattering at right angle to the incident beam. The incident light has a particular frequency. If the scattered light has the frequency same as the incident light, then the scattering is called as Rayleigh scattering. However, it has been observed that about 1% of the total scattered intensity occurs at frequencies different from the incident frequency. This is called as Raman scattering. Raman scattering can be thought of as 2-photon process. The electrons have different vibrational levels. They are defined by specific energy differences. When an incident monochromatic light interacts with an electron in the sample, the electron absorbs energy from the incident photon and it rises to a virtual state of energy. The energy transferred is given by the formula E equals h nu, where nu is the frequency of incident photon. The electron then falls back to an energy level by losing energy. If the energy lost equals to the energy of incident photon, the electron falls back to its initial level and in this process emits another photon. Since the energy lost is equivalent to the energy of incident photon, the released photon has same frequency as the incident photon. As the frequency is same, Rayleigh scattering occurs. However, sometimes electrons, when losing energy from the virtual state, can fall back to a different vibrational level. In this case, the energy lost by the electron is different than the energy absorbed from the incident photon. As a result, the photon emitted by the electron has energy different than the incident photon. This is possible when the frequency of the emitted photon is different than the incident photon. This gives rise to Raman scattering. Depending upon the final energy of the electron or final vibrational level of electron, Raman scattering can be separated into Stokes line and anti-Stokes line. If the frequency of scattered photon is less than the frequency of incident photon, Stokes lines are observed on Raman spectrum. This happens when the electron absorbs energy. Similarly, when frequency of emitted photon is greater than incident photon, anti-Stokes lines are observed. This means that energy is released by the electron. The Raman spectra gives the molecular fingerprint and it is different for different molecules. By studying the spectra, one can identify the rotational levels and thus a particular molecule. This helps in performing qualitative analysis. Similarly, the intensity of a particular Raman line helps
Commonly believed that the ocean is blue because of its reflecting the blue sky. But this is a misconception. The ocean is blue because the way it absorbs sunlight according to the National Oceanic and Atmospheric Administration (NOAA). When sunlight hits the ocean, the water strongly absorbs long wavelength colors at the red end of the light spectrum as well as short wavelength light including violet and ultraviolet. The remaining light that we see is mostly made up of blue wavelength. However, NOAA notes that the ocean may take on other hues including red and green if light bounces off objects floating near the surface of the water such as sediment and algae. Just how blue the water is depends on how much of it is available to absorb the light. For instance, water in a glass is clear. There are not enough water molecules to really absorb the light. But ocean water appears blurred the further you travel down the water column. The water molecules absorb infrared, red and violet light first and then yellow, green and violet. Blue light is absorbed the least, giving it the greatest ocean penetration depth according to NASA. This fact is clear if you look at unedited underwater photos that were not taken with a camera flash or another artificial light source. Even the most vibrant of tropical fish look blue.
Good morning to one and all. I am Amrin Fatima from 7C. Why does the sky appears blue? The white light coming from the sun is scarcely made up of all the colors of the rainbow. As white light passes through our atmosphere, gases and particles in Earth's atmosphere scatter sunlight in all directions. Violet and blue light have the shortest wavelength and red light has the longest. Therefore, blue light is scattered more than red light and the sky appears blue during the day. What makes a sunset red? As the sun gets lower in the sky, its light passes through more of the atmosphere to reach you. Even more of the blue and violet light is scattered, allowing the red and yellow to pass straight through to your eyes. Also, larger particles of dust and water vapor in the atmosphere scatter more of the reds and yellows, sometimes making the whole western sky glow red.
Good morning everyone. I am Arya here from 3rd C. Today is C.V. Raman's Day. In this occasion, I am sharing a quote by C.V. Raman sir. The essence of science is independent thinking, hard work, and not accumulating. Thank you.
Hello my dear friends. My name is Jaron Fransanitsen from D. Today we are celebrating C.V. Raman Day. Here is a quote of C.V. Raman. Ask the right question and nature will open the door to her secrets. Thank you.
Good morning everyone. I am Sarafik from 4th E. I'd like to say the famous quote of C.V. Raman. I am the master of my failure. If I never fail, how will I ever learn?